In this section, we are going to discuss expected value. Expected value is used to determine the expected results over the long term. To calculate the expected value, we are going to multiply the probability times the payout for each outcome. Then we're going to add that all together. This formula that you see right here is everything I just said in words, now put into math notation. The probability is going to be P of X sub I, and the payout will be just that X sub I. So the payout times the probability. Then the part where it says add together, that's what this uppercase Greek sigma means. It means I'm going to do it for every single row, and then that sigma means I'm going to add it together. So I'm going to do payout times probability for every single outcome, and then I'll add them all together. Now, one thing to keep in mind when we're working with expected value is the law of large numbers. This means that we have to repeat our experiment or our data or whatever it is we're looking at. We have to repeat it many, many times to get the true probability for that problem. Now, I know that formula seems a little overwhelming, but let's do an example and you'll see it's not too bad. Example 1 is your friend Marty describes a game where a player throws a die. If an odd number is rolled, the player wins an amount paid by Marty equal to the number on the die times 100. If the number is even, Marty will win the number on the die rolled times $100 from the player. And he wants to know how much he would make or lose on average. So let's organize our data into the following table. We'll start with outcomes. So a die has 6 sides, and the sides are numbered 1, 2, 3, 4, 5, 6. And the probability of rolling each of those is 1 out of 6, so 1/6. So the probability will 1/6 all the way down this column. Okay, now let's figure out the payout. It says that if an odd number is rolled, the player would win the amount paid by Marty equal to the number on the die times 100. So let's think about this. If somebody rolls a 1, then Marty will pay 1 times 100. So that'll be 100. Now, how do we express paying something out if we're losing that amount of money? Well, we do that with a negative number. So this will be negative 100. All right, and let's look at the 3 now. 3 times 100, that's going to be 300. And this is an amount of money that Marty is paying out. He's losing this money, so this is negative 300. And we'll do the same thing for 500. So 5 times 100, that's 500, but it's money he's losing, so that'll be a negative. Now let's look at the even numbers. If somebody rolls an even number, it'll be that number times 100. So for example, 2 times 100 is 200. Now that is money Marty will get. He will receive that money. It will be a positive amount for him, so that will be a positive 200. And we can do the same thing with 4 because that'll be positive 400, and 6 will be positive 600. So let's look at the table. We have 1/6 is the probability, and the payout is negative 100 for a outcome of 1. So I'm going to multiply probability times payout, so 1/6 times negative 100, that equals negative 16.6667. Then I'll do it again for the next row. So 1/6 times 200, that'll be 33.3333. Then the next row, I have 1/6 times negative 300, that's negative 50. Next row, 1/6 times 400, that is going to be 66.6667. The fifth row is 1/6 times negative 500. That's going to be negative 83.3333. On the last row, I have 1/6 times 600. that equals 100. Now, the last part of the procedure in the definition says we need to add up all the products. So I will add up all the values in this new column that I created. So negative 16.6667, 33.3333, and the remainder of the numbers. And if you put that on your calculator, you get 50. So what does this mean? This means that Marty will average $50 per game in the long run. So if he were to play this game a lot of times, he would average $50 per game. So let's say he played it once, he lost $100. He played again, he lost $300. And he played it again, he lost $300. And then maybe he won several times after that. He won 600 and then 400 and 600. If we were to add up all those values, if he were to continue on to do this, he would average $50 per game in the long run.